Good morning, afternoon, or evening, and thank you all for being with us today. I'm Gustavo Lopez, and it's a pleasure to host this webinar brought to you by Septentrio. In this session, we'll look at the JammerTest 2025 results, resilient GNSS in an era of rising jamming and spoofing. GNSS is a core enabler technology across defense, critical infrastructure, autonomy, and industry, yet GNSS is facing growing attacks worldwide, and jamming and spoofing now have real-world operational, safety, and economical consequences. And today's speakers will discuss how the threat landscape is evolving and what practical technologies and the test approaches are being used to ensure trusted navigation in challenging environments. We will also review the highlights from the latest JammerTest, showing real-world GNSS resilience against interference. The interest has been overwhelming. Actually, we have a record of more than 1,000 registrants from around the world and across different types of industries for today's webinar. You will have an opportunity to ask questions directly to the experts, and we will have also a Q&A section also at the end of the presentation. So please don't hesitate to ask your questions. You can use the GoToWebinar console as is shown here on the screen. And if you experience any technical difficulties, you can also use the same Q&A box. Also, for people that would like to obtain the recording of this webinar, not a problem. We will make it available to you using your registration information. But before we begin, let's take a moment to align on what we mean by jamming and spoofing and why this topic is so critical today. GNSS jamming is the disruption of satellite navigation signals by transmitting radio interference on the same frequencies used by GNSS. They really destroy the signals in that level. Spoofing, on the other hand, is a more subtle and often more dangerous attack as it manipulates GNSS signals to mislead receivers with false position or even time information, sometimes without the user immediately noticing. So both are becoming more frequent, more accessible, and also more impactful. From the defense to the autonomous systems, GNSS is a mission-critical system, and interference is really no longer theoretical. And this is really why we wanted to have this webinar and to talk about resilience, not just from the technology part, but also across the entire GNSS ecosystem. This webinar highlights results from the JammerTest in Norway, a unique and large-scale field testing event assessing GNSS interference and resilience in realistic conditions. And these findings are also enriched by policy and end-user perspectives, with speakers covering the GNSS policy, the major resilience testing insights, and also real-world receiver use cases from a leading live drone show operator. Actually, it's great to see that we have also this specific use case there today. Together, these perspectives send a clear message. GNSS resilience is no longer optional. It's a shared responsibility and a fundamental requirement. So we really encourage you to have an active participation. Feel free to ask questions during the presentations using the chat box, and your engagement will help to make this a lively and productive discussion. We hope you enjoy the webinar, and we invite you to stay also to my favorite part also of this webinar, which is the Q&A section at the end of the presentations. But before we start, let me also introduce you to our expert panel today. We have Lisa Dyer, and Lisa brings a strong ecosystem and policy perspective on GNSS with a very deep insight into why jamming and spoofing are increasing and why protecting GNSS has become a strategic policy. She works closely with the industry, the government, and the infrastructure stakeholders to raise awareness of interference risks and to promote resilience across the GNSS ecosystem. Joining us to provide the results overview of the Norway test campaign, we also have Samuel Heinen. Samuel is a GNSS expert at Septentrio who brings deep expertise in GNSS resilience, focusing on how receivers detect and mitigate jamming and spoofing, and he will share some of the insights from the real-world interference testing in Norway. And to complete the full picture, we are also pleased to include the end-user perspective on GNSS resilience. So we will also hear from Hyun Lim, who is the CEO and the co-founder of UVify. Hyun brings a deep expertise in the live drone show systems and also on the large-scale live operations that these drones have, with first-hand experience on the GNSS challenges that directly impact either the drone synchronization or the safety or even the show reliability. So with that, I'm really excited to hand things over to our expert speakers today. And to kick off the webinar, let me welcome Lisa Dyer, who is Executive Director of the GPS Innovation Alliance. Her organization promotes GPS, GNSS, and also complementary space-based PNT systems, and their vital role in the public safety, the critical infrastructure, and the global economy. And Lisa brings over 25 years of experience across the public policy, the national security, and the technology, all the way from the US Air Force and the State Department to the private sector. She will set the scene on why jamming and spoofing are increasing and why GNSS resilience is not anymore, again, just a small problem, is also now a strategic priority. So Lisa, really thank you very much for joining us today, and over to you. Please give us your presentation.
Thank you, Gustavo. Thank you, Joe, Francesca, and everybody who made today possible. It is a really important topic and one I'm really excited to be here to talk about. So the really exciting part, Gustavo, next slide, please. Really exciting part of this, and the good news that I have to deliver today, is that the PNT community is really stepping up to solve those jamming and spoofing challenges that we are seeing in every region around the world. Next slide, please. As Gustavo mentioned, this is no longer theoretical. This is absolutely a reality, and that does have strategic implications, not only for the governments involved, but for industry, and it has strategic implications for public safety and global commerce. As we know, the Ops Group report in September of 2024 was one of our first indications that spoofing is a reality. It was impacting and continues to impact aviation throughout Europe and the Middle East. There are also impacts that are really important to the United States and Europe here that the policy community has mentioned to us. First of all, in the United States, our customs officials are interdicting an increasing amount of illegal jammers and spoofers coming into the United States at an 830% increase. That's tremendous. And let me re-emphasize the word illegal. Jamming and spoofing in the United States is absolutely illegal. So there's a lot of work we have to do in that area. In June of 2025, there was a letter exchange between the governments of Estonia, Finland, Latvia, and Lithuania, talking about the harmful interference that they are experiencing. And it directed it towards Russia. And Russia came back and said, thank you, we're going to, essentially, if I'd summarize it, say we're going to continue to do this because we're concerned. We at the GPS Innovation Alliance are seeing this in an alarming way. We think that this is an important thing that we need to do because of the public safety. It's an important issue that we need to tackle because of the public safety implications and because it is impacting economies. So we put together a letter to highlight exactly why we think this is important. And we put together a series of recommendations that we sent to the Secretaries of Defense and the Secretary of Transportation in the United States. We were really pleased to see a letter that came out just last month from 13 coastal states in the Baltic Sea and North Sea, warning of growing risks to maritime safety. We were glad to see this, one, because it shows a step up of government involvement in addressing these risks, but also highlights that it's not just GPS and Galileo and other GNSS systems that are being impacted, but also AIS, just like we're seeing in the cyber world, increased attacks. Next, please. Let me turn a little bit to the GPS recommendations that we made to the US government. First of all, we think that the entirety of the US government needs to be involved in tackling this issue. It is that serious. We offer technological changes as well as policy changes. Let me just highlight a couple of those. First of all, on the technological changes, we recommended that controlled reception pattern antennas are an exceptional way that different types of infrastructure can introduce more resilience to jamming and spoofing. The United States P&T Advisory Board put together a terrific graph that you see on the right that shows exactly where controlled reception pattern antennas can make a difference. Tied together with multi-frequency receivers, those multi-frequency receivers and CRPAs together are an even stronger response to jamming and spoofing, as you see in the bars on the far right of that graph. There's a lot to do on the policy side too, ranging from diplomatic conversations behind the scenes to try to get this harmful interference to stop. But we also needed to make sure that CRPAs were removed from the US international traffic and arms regulations. And I'm pleased to say in that September of 2025, the United States did do just that. And now certain types of CRPAs are eligible for export. We also recommended that streamlining certification standards, particularly for aviation and other public safety applications, would be an important next step. Those standards are extraordinarily rigorous for very good reasons. We're putting our lives at stake when we get on a plane anytime. But are there ways to streamline this so that we can get those CRPAs and those multi-frequency receivers in those public safety applications more quickly? And then finally, next slide, please. Our recommendation was to increase the funding and accelerate the third generation of GPS. As you can see here, there are some important improvements in anti-jam capabilities on those satellites, but notably, as our recommendations said, there's no counter-spoofing capability in the GPS program plan right now, and we recommended that there will be. Next slide, please. It's not just GPS and other systems that are trying to look at anti-jam capabilities. I'm excited to report that they are coming up in other ways, and that has important implications for policy, as well as industry's ability to become more resilient. We were delighted to see Galileo's OSNA capability become operational in July of 2025. We're really excited to see the use cases where it is best put together. In August of 2025, Navigation Technology Satellite 3 was launched, and what's notable about that is Chimera, an anti-spoofing capability, is on that satellite. I checked for more information about how the current testing is going with Chimera, and as of last week, they reported that the testing continues, but they're not yet ready to release public results. We are just as eager as you to hear more about what that looks like. Also very exciting are some advances that Septentrio and others are making on the ground to try to increase the resilience to jamming and spoofing. Of course, the advanced interference monitoring and mitigation techniques from Septentrio are really important. And then there are also a number of advancements that are being made comparing GNSS signals within phones, for instance, to say one of these isn't behaving correctly, let's throw that faulty signal out. Or comparing GNSS signals to correction services and saying something doesn't look right here and let's not use that particular signal. So important advancements that are coming forward to improve, to make public safety safer, as well as to ensure that commerce occurs unimpeded across the world. Next slide, please. Complementary position navigation and timing also has an important role to play at some point in the future. The Federal Communications Commission in the United States put out a notice of inquiry about a year ago asking what's out there, what's available, and what we saw were that there are dozens upon dozens of proposed space and terrestrial systems in various stages of development, and more importantly, various stages of deployment, whether they're available worldwide or just in a localized capability. Some of those systems are planning to operate in the L-band, where GPS, Galileo, and other GNSS operate. Some, like TrustPoint, will transmit their signals in C-band. Terrestrial systems looking in the lower 900 megahertz, and then companies like SpaceX that are offering signals of opportunity, thinking that they can derive some position and navigation signals from existing signals that they're already transmitting. When we take a look at those different capabilities that are out there. We ask, what stage of development and deployment is this system in? What does it bring to customers? What use cases will the capabilities deliver? Is it for a precision capability, such as agriculture and construction, or is it more appropriate to the rideshare capabilities that you pull up on your smartphone? Are these systems capable of passing the requirements, the stringent public safety requirements that I previously mentioned is a key question. And then finally, the time for integration is key. And it's really exciting to see companies like TrustPoint and Hexagon coming together in a strategic relationship to integrate those C-band signals into receivers and devices so that they can be made available to people around the world so that the types of systems that they are using are resilient to jamming and spoofing. One of our recommendations to the Federal Communications Commission is to actually define resiliency. We in the PNT community and the regulatory community use that word very frequently to say we need more resilient systems, but there's no real agreed upon definition. So we offered one, and we thought that resiliency meant that systems are diverse in their orbits, diverse in their signals, and diverse in their frequencies. Next slide, please. Turning to JammerFest, I'm excited to report that the University of Colorado Boulder and Lockheed Martin put together a project to quickly detect and locate problematic emitters using Android phones. They did this as a result of 2 real-world experiences with Denver International Airport and Dallas International Airport. It took several days to identify the source of the jammer that was impacting air traffic at Denver, and in Dallas, the source of interference was never publicly identified. So they conducted some experiments at JammerTest, and they're now reporting those results to government agencies and manufacturers to see what more can be done to help reduce the time to identify problematic emitters. Next slide, please. I'd like to conclude by just expressing our deep thanks to the Kingdom of Norway. Its government agencies, its residents, and its workers have come together to create an environment for the PNT community to test out its receivers and devices and satellite signals to figure out how best we can make technologies that are more resilient to that jamming and spoofing, to really preserve the public safety capabilities that rely on GPS, Galileo, GNSS, and to make sure that our economies continue to operate in the way that they should and realize all the benefits from GPS, Galileo, and GNSS. Really thank you, Kingdom of Norway, for making this possible. I'll turn it back over to you now, Gustavo.
Thank you very much, Lisa. I really appreciate that. I totally agree with you that these test results on Norway are definitely key for the community. So very much thank you for that, and especially for the encouraging message that you gave us with the focus mainly on the progress that things are happening. There is a lot of progress, not only from the receiver manufacturers, but also from the infrastructure side. So really nice to see that, and also how the testing events are also moving forward the resiliency aspect as well. So thank you very much for that. And it's actually great for moving to the next speaker. But before we move to that, I would like actually to get a bit of feedback from all of you. So I will put a poll in this here in the screen for all of you. Give me a minute. And the question is the following. In your operations, what matters most to you when GNSS is disrupted? Is it the fast detection and the clear alerts? Is it the safe fallback or graceful degradation? Is it the rapid recovery after interference? Or is it the full continuity without GNSS? So I'm getting lots of answers in the meantime. But yes, I think especially when GNSS is being disrupted with this either jamming or spoofing, applications are behaving in different ways, or they are reacting in different ways. No? So I see definitely the detection and the clear alerts is definitely getting some important feedback here. but I'll show you the results in a minute. Now, we have already quite a lot of people that have voted. So let me end it now and share the results with all of you. So you can see here, so yes, we have 56% of people that believe that the fast detection and the clear alerts are really important. And actually that will link very much to the nice presentation also that Samuel has, that he's also emphasizing some of those alerts as well. And the second point that we have here is the full continuity. I think everybody wants to have, of course, mitigation, and that also is a great gateway for the next presentation that we will have. So thank you very much for that. And now I will move to our next speaker. So I'm pleased to introduce Samuel Heining from Septentrio. With a background in electrical engineering and digital signal processing, Samuel works as a DSP engineer and data analyst, focusing on improving GNSS resilience against jamming and spoofing. And he was also part of the JammerTest Norway 2025 team, where he helped to analyze the real-world interference performance. So Samuel will share the insights from the receiver, but also from the signal processing side on how GNSS resilience is being achieved in practice. Samuel, we are very keen to hear the results from JammerTest, which is indeed one of the major topics also of today. A truly valuable event, as Lisa has highlighted as well, for the GNSS community. So the floor is now yours. Thanks a lot.
Hello, thank you for that nice introduction, Gustavo. So before I get into this, I will give a bit of an overview of what I will be talking about. If the slides move, of course. Yes, here we go. So first of all, I will give a bit of an overview of what JammerTest is. It's this controlled testing for resilience against jamming and spoofing that we can use to improve our products. And then I will go over the results for both the jamming and spoofing scenarios that they do there, and see how our receivers are able to keep their position during jamming against multiple different types that we will also go over. For spoofing, it's more about misleading the receiver, and then the receiver has to try to keep the correct position and detect all of this spoofing. Now, before we actually go into this, it's also important to give you a bit of an overview of our products so that you can follow along, as we actually have different levels of resilience with our different products. So for instance, we have our Mosaic G5P1, which has the basic level of resilience. This is stepped up by the P3 or P3H variants. Then even higher than that, you have the premium resilience with our AIM Plus interference mitigation, among which the Mosaic X5. And then finally, we also got a chance to bring some development there. And then we will also show some nice results that we got with that. But first of all, what is JammerTest? I'm not sure. Oh, yeah. What is JammerTest? It's this advanced outdoor jamming and spoofing test that they do. They do this luckily at a very remote location, somewhere in the northern part of Norway, so that they're not disturbing too many people. And it's quite sophisticated multi-constellation, multi-frequency spoofing with a large variety of different jamming and spoofing scenarios. Like I said, it's in Norway and also organized by the Norwegian governmental agencies. And they do this quite well. As you can see, there are quite a lot of happy participants actually from authority, industry, or academia, all enjoying this awesome event. This is already the third time that we go there, actually, 3 years in a row now. So it's really starting to add nicely to our long heritage in all of these events that we join, to really stay on top of in terms of resilience against all of these threats. Now this year, what did this look like? We had both a static setup and a test car. So in the static setup, all the receivers were sitting nicely inside of a box. And then we had to do we did the kinematic testing with the test car that we actually had to drive all the way from Belgium to Norway. So it's as we say, we go the extra mile, but rather miles or thousands of them. And then also, of course, we bring quite a lot of receivers, 34 this year, both Septentrio receivers as well as competition to have the comparison. So that also means quite a lot of data. So in all, it's the message here is that we really put in the effort to stay on top and improve our products the best we can. Okay, so with this introduction, we can now go over to the results, and we will start off with the jamming part. And we will do this for many different jamming categories. So we'll start off with CW one. This stands for continuous wave jamming, and what this means actually, CW is actually one sinusoid, which means one frequency. But of course, they want to make it a bit more difficult, and then they do this at multiple frequencies, so multiple CWs at once. And here they have this scenario where they do it at 5 different frequencies from different constellations. Then they use this special emitter. They call this the Porcus-Meyer. It's a very powerful one. Actually jams 50 watts, and this can be estimated to jam a radius of about 50 kilometers around. And then as we know that the receiver is at about 2 kilometers, then you can really see on the map that it's right in the middle of the danger zone. So mitigation is important. And for this, to be a bit more technical, they use notch filters, which work quite nicely. It's also quite common in the field, so it's a really relevant scenario. We, for instance, see this as common practice in the Middle East. But then for the results, we'll have to see that you need this advanced resilience or premium resilience from our receivers that use these notch filters to keep position 100% of the time. How can you see this from these plots actually? Because all of these bars, they represent the 100% of the scenario, and then the bar is colored in the way of what percentage of the time did it either in red have no position, in purple in inaccurate position, and then in blue just an accurate position. So the resilience from Septentrio receivers becomes clear here, as we see from competitors that they're not always able to keep position against this type of jamming. And if they do, then they report to have a position, but as you can see on the map, then it's often not accurate, as here the error even goes up to in 3D to 100 meters, unlike the Septentrio receivers. Now, of course, this is only a very first type of jamming. They test multiple types of them. So for the next one, oh, that's one slide too far. For the next type of jamming is the chirp jamming. So now it's not just the one frequency, but rather they sweep a range around the center frequencies. And so again, they pick the same 5 frequencies around which they will sweep to this chirping jamming. In this case, the rejection radius is about 7 kilometers, so the receiver is still right in the danger zone. So mitigation is needed, which is provided by our AM+ technology. Also important here to know is that this type of jamming, this chirp jamming, is also quite common as a commercial jammer, so it's quite accessible, which makes it especially dangerous for more common applications, or as you will see later on as well. Now, how does the mitigation fare here? Here we see that it's actually this AM+ technology is really required, as we see from the Mosaic X5, which has this AM+ part of the premium resilience that is able to keep an accurate position 100% of the time. Now, even more excellent is actually some development that we were testing there. As you can see by the green bar, this one was actually against this high-power chirp jamming, able to keep an RTK position 100% of the time, thanks to its high-power resilience. So stay tuned for that. For the competitors, actually, we saw that they did not have any mitigation against this type of jamming, against this chirp jamming, as we see from the bars as well. And in the case that they had a position, then it was also really not accurate, as indicated by the median error there in the purple part of the graph. And actually, this failure to mitigate the chirp jammers and then having large position outliers is something that we saw in multiple scenarios. So here was a more extreme one, where you can see in the orange circle the actual location where the Septentrio receivers were. And then a competitor that, due to all this jamming, went really hallucinating and went all the way into the sea. So the position was not trustable at all. Okay, so far so good, but there are also a more advanced type of jamming, even a really extreme military type of jamming. This is called PRN jamming, stands for pseudo-random noise jamming, where mitigation is still possible, but it's really challenging. And to even increase our resilience a step further, we also make use of a special antenna, the one that Lisa also already mentioned. The CRPA, it stands for Controlled Reception Pattern Antenna. And basically what it does, it can suppress jamming signals from certain directions. In our setup, the CRPA that we were using was called the Gadget 310 from Novatel. And just to give an analogy here to what it is doing, you have, like, imagine that you're in a room full of people and you're trying to listen to a certain person in that room. You really have to direct your focus and mute all the sound coming from the other directions. And that's exactly what this antenna is doing as well. It tries to mute the direction the jammer is coming from while listening to the real satellites. Now, what are the results for this type of jamming? So for this, we had actually a car driving along the road. I've Yeah. And then first we take a look at a regular receiver that has no mitigation at all with a regular antenna. And then first we can see as it's driving along that the jammer is shielded by the fjord. But then once it comes out of hiding, kind of, it loses its position. Now this can actually be greatly improved when if you use one of our receivers with the next level of resilience, then you can see that this improves dramatically, although there is still a small gap in there. And this is where the CRPA antenna really steps in, as it is nicely compatible with our mosaics and can make sure that it keeps position all of the time during this scenario nicely. So I think that's mostly covered it for the different types of jamming and how to mitigate them. But it would also be very interesting to also take a look at the situational awareness that our receivers have. So what are we trying to show here? We show a spectrogram based on our baseband samples, where on the y-axis you have the frequencies, and then they move along over time over the x-axis. So here what is happening, we see that there is a sweep of frequency that goes from B1I all the way over L1 to GLONASS L1. And then after a while, it goes back down. Now this, which frequencies are being jammed at which time is also something that our receivers report. This is done in the RF status message, and when we interpret these results and plot them as well, we see that it nicely corresponds to what is happening in real life. And of course, this is very valuable to the users, as simply from this simple output of the receiver, it can learn the situation and know what is going on. Okay, that then covered it for the jamming part, nice results there. But now let's also go over to the spoofing part, just to reiterate a bit, because this is more complicated than jamming. What is spoofing actually? The intention of the spoofer is to try and give the receiver a wrong position without the receiver noticing. It can do this by trying to mimic satellites actually, and that's to do the sophisticated creation of fake satellite signals using advanced equipment for that, like we showed there, a GNSS simulator or a software-defined radio. And then it emits this together with the real live signals from the satellites. And then the receiver needs to distinguish between all of these signals and keep the correct position. What can this look like? Here, for instance, we had a spoofing attack where on the left side, the target kind of is shown, where they try to spoof the receivers on a circle path. And to make it even more difficult, actually, they also include some jamming while doing all of this spoofing to really challenge the receivers. On top, then we see what happens when the receiver fails. For some competitors, we see that they can either go on the spoofing path or they get completely confused by all of the spoofing and jamming that's going on. On the other hand, on the bottom, we see that the receivers that were able to keep the correct position were our mosaics. And here we see an example of the mosaic X5, which really stays spot on and is not affected. Now, thanks to this event, we saw actually quite a lot of these scenarios. We also shared some on our social media, and in the next part of this presentation, Ian will also show some nice examples of the spoofing. But of course, there are also some examples where it doesn't always go good, and that's really the real value of JammerTest. They do this advanced state-of-the-art spoofing where sometimes all receivers even were spoofed. They were following some drone path, which was nicely spelling JammerTest, of course. Here we see some examples from some competitors, but even our receivers were sometimes on the wrong position in some cases. Now, this is why JammerTest is so important, because we learn from this, we identify the problem, we now know how to tackle this, and we're working on a solution. Next to that, of course, it's also quite important, and that once or when it happens that this position is wrong, that the receiver alerts this. And this is why also a part where our receivers are very strong. They do this consistently. And the question then becomes, does every receiver? And for this, we kind of want to go over the full day of spoofing, like in red is highlighted when the spoofing epochs are happening. And then we show the different detections for different kind of receivers. Here we see that the spoofing flag for the Septentrio receiver is doing quite well, as it nicely aligns with the red parts. For competitors, it can be a bit different. For instance, we see some competitors that do not have any spoofing detection at all, so you cannot know whether the position is correct or not. Other competitors, they kind of offer some spoofing flag, but it's a bit ambiguous. Like they offer two flags, so it's not clearly which one to use, as well that both of them are not really as accurate as compared to the Septentrio one. And then finally, we see also some spoofing flags that look a bit more promising, maybe not as accurate, but it looks okay. But for this, you also need to double check, of course, and make sure that it's not too sensitive. Are there not too many false positives? And what's the perfect way to do this at JammerTest? That's to look for a full day of jamming. So now the red part is jamming only, no spoofing. From the Septentrio receivers, we see that there are no false positives. The spoofing flag is not budging. While for all the other competitors, we see that at least if they have a spoofing flag, that it's triggering quite some false positives during the jamming parts as well. So here the conclusion can only be that Septentrio really excels in this trustworthy spoofing detection, which is quite important. Now, okay, I think that covered it for this year's JammerTest, the most important things that we showed you. So let's conclude. Overall, we saw some great performance against jamming, against the multiple different types, while we saw the competitors struggle. For the spoofing part, we saw lots of strong and sophisticated scenarios being tested, where we saw great resilience, although they sometimes were also causing position outliers. But this was always detected, of course, unlike the competition. And then all in all, to finish it off, it was simply an awesome event for us for improving the resilience of our receivers and to help protect your applications. We're already looking forward to the next edition and preparing for it. And I think that concludes it for my part. So that's back to you, Gustavo.
Thank you, Samuel. It has been very nice to see actually the highlights actually that you have given about the test, but also the very interesting creative ways that actually the event is also bringing new type of test. And also let me highlight also the synergies that this brings, right? As you notice yourself, there is a lot of community attending the event all the way from the public sector all the way to the private sector. So definitely very nice to see that. Thank you very much for that presentation, Samuel. And we'll conclude the speaker lineup with Hyon Lim, who's the CEO and co-founder of UVify. This is a great way to complement this webinar, as Hyon brings the essential end-user perspective. With first-hand experience running large-scale light drone shows, he provides a clear insight into the real security and resilience needed in live events, where GNSS reliability is really fundamental for the safety, for the synchronization, and also for the successful performances. So, Hyon, it's really very nice to have you. I know that you are also in Korea, so thank you very much for joining at this time. And please give us your presentation.
Hello, everyone. Hello, everyone. This is Hyon Lim from UVify. Today, I'd like to talk about how we are pushing GNSS performance to its absolute limits in the real-world drone applications, especially in precision-critical swarm operations. In this talk, I'll walk through the technical challenges I gained from the field deployments and testing. Including spoofing and jamming scenario. Let's dive in. Before diving into the technical deep dive, I wanted to highlight the milestone that we're extremely proud of. We set a new Guinness World Record by flying 5,293 drones simultaneously. This achievement wasn't about just a number. It was a demonstration of system reliability, GNSS precision, to manage thousands of aircraft in the perfect synchronization. Record-setting shows like this push our technology forward and validate it in real-world, high-pressure environments. And they give us the confidence as we continue developing even more resilient and precise swarm light show. Here you can see a glimpse of what our technology looked like in the real world. These images capture large-scale swarm operations where thousands of drones take off from complex shapes and execute precise maneuvers in challenging outdoor environments. What's important to recognize is that every one of these drones depending on reliable, high-precision GNSS to stay exactly where it needs to be. Even a few centimeters of drift can cause a visible distortion, break choreography, or in worst case scenario, create a collision risk. These field deployments are where we validate our engineering in the cold, in the wind, over the water, in urban RF dense areas, ensuring that our systems deliver consistent performance under real operational stresses. This is an environment where UVify continuously pushes the boundaries of the GNSS-based navigation. So our goal with IFO has always been simple: to provide the creators, producers, and operators with a tool they can trust, one that performs flawlessly night after night in any environment, anywhere in the world. IFO, the platform where drone light dreams take flight. IFO isn't just a drone, it's a purpose-built system engineered for reliability, safety, and artistic precision. Now let's take a close look at IFO, the world's #1 Sommelier drone. Everything about IFO has been engineered with one goal in mind: delivering flawless drone light show at scale, night after night, anywhere in the world. So we developed the module with the Mosaic X5. This module is actually deployed in our Sommelier drone, and we are actively testing. And we're happy to share some results that we performed with the actual jammers and spoofers in the field. Okay, next slide, please. Now let's talk about one of the most critical challenges in the largest scale drone light shows: GNSS jamming. Drone show depend on centimeter level positioning accuracy to maintain perfect formations. When GNSS signals are jammed, even briefly, drones can drift, lose position, or deviate from their choreography. Even a small positional error becomes obvious when you are flying hundreds of thousands of drones side by side. This is why GNSS resilience is absolutely essential for safe, reliable, large-scale drone performances. Next slide, please. Here we're looking at the results from one of our spoofing test scenario. In this test, we flew 5 drones equipped with different GNSS receivers. Among them, 3 drones using other receiver were successfully spoofed and forced to land, unable to maintain reliable navigation. But 2 drones equipped with the Mosaic X5 module, drone number 6 and drone 10 in this figure, survived the spoofing attack and continued all the way to the intended destination. This demonstrates a key point: not all GNSS receivers behave the same under hostile or degraded conditions. The Mosaic X5 showed a significantly stronger resilience, maintaining integrity even while other receivers are failed. These kinds of controlled spoofing tests are essential for us because they simulate the exact threats our drone can encounter in the real world, whether it's accidental interference, environmental RF noise, or deliberate signal manipulation. And most importantly, it shows why investing in a resilient GNSS is not optional for some operation. It's a foundation. This is a video of actual test. You can see that the other drones are lost its location. They are forced to land because the extended command that they're running on the drones feel that the GNSS is a problem, whereas the other 2 drones with the Mosaic X5 is successfully continued the mission. Next slide, please. This slide summarized the results of our spoofing test in a simple, clear way. out of the 5 drones we tested, 3 drones equipped with the other receiver were spoofed and forced to land, unable to maintain the navigation integrity. But 2 drones with using Mosaic X5 receiver, drone number 6 and drone 10, survived the spoofing attack and successfully reached the intended destination. Here, you're seeing the log of from the experiment, and here you can see the spoofing. When spoofing injected, usable measurements to keep position stable, whereas the other receivers are confusing and lost its location. The result reinforces the key message. GNSS resilient isn't theoretical; it's measurable. Under the same conditions, different receivers behave very differently, and the Mosaic X5 consistently demonstrates the robustness required for real-world swarm operations. These kinds of tests help us validate our system design and ensure that UVify drones remain reliable even in the challenging or hostile GNSS environments. Now we're looking at the Mosaic X5 log from the drone number 10 during the spoofing test. This chart shows the CNO values over time, essentially the signal strength and quality of the GNSS measurement. You can clearly see the point where spoofing was injected into the environment. The moment the spoofing begins, the CNO values for many satellites collapse or fluctuate unpredictably. What's important here is that despite the hostile GNSS environment, the Mosaic X5 module on drone number 10 continued operating, maintained enough signal integrity, and ultimately completed its mission. This stands in contrast to the other receiver that of the fully lost navigation and were forced to land. This kind of signal level insight help us to understand exactly how and why certain receivers survive spoofing attempts, and it reinforces the importance of using GNSS hardware that can maintain stability even when the environment is actively being manipulated. Next slide, please. Now let's take a result from our jamming test. In this scenario, we flew 5 drones equipped with the different GNSS receivers along the pre-planned route. Under active jamming, 4 drones using the other receiver lost their position, and we are forced to land. In contrast, 1 drone equipped with the Mosaic X5 module, the vehicle number 11, maintained navigation and successfully reached the intended destination. What this tells us is straightforward. Under identical RF conditions, the receiver resilience diverges sharply. The Mosaic X5 demonstrated ability to sustain tracking and integrity, even as the other receivers degraded below the operational threshold. These controlled jamming trials mirror the kinds of interference we face in real events, from dense urban RF environments to accidental emissions near the venues, and they help us to harden both our hardware choices and our operational safeguards for the larger scale shows. The bottom line, the GNSS resilience isn't nice to have, it's a mission critical for safe, synchronized swarm performances at scale. Next slide, yeah. Here we're looking at the drone log from vehicle number 1 during the jamming test. On the left, you can see how the numbers of tracked satellites and GNSS status value begin to degrade as jamming signal intensifies. Eventually, the GNSS status drops all the way down to no fix, meaning that the receiver is no longer able to provide a reliable navigation solution. What's important here is how clearly the data shows the progression of the jamming effect. You can see the GNSS quality collapsing step by step, first with instability of fluctuation and eventually with a total loss of fix. This is exactly the kind of behavior we observe when a receiver is unable to handle the interference. This log reinforces why GNSS resilient hardware is essential. Next slide, please. On this slide, we're comparing GNSS altitude in green, in red, against the aircraft barometric altitude in green. So during the jamming event for the drone number 11. So what you will notice first is a sharp, unrealistic jump in the GNSS reported altitude, while the barometric altitude remains stable. This divergence is exactly what we expect when a receiver is being jammed. The satellite-based solution becomes noisy or unstable, but the onboard baro sensor continues to reflect the aircraft's true vertical state. So when GNSS altitude starts to spike or collapse, we treat it as a signal quality problem, not a real flight dynamics issue. So our flight stack and safety logic look for this kind of sensor disagreement, so we can de-weight the bad inputs, preserve control, and avoid unnecessary fail-safes while still keeping the margin for the safety. On this slide, we're looking at the Mosaic X5 CNN log from the drone 11. You can see a clear interval labeled jamming, where the CNO traces become erratic and degrade, indicating a hostile RF environment. This is receiver experiencing elevated interference. Multiple satellites drop in quality simultaneously, and several tracks fluctuate or collapse as the jammer impacts the spectrum. What matters operationally is that even under this interference, the Mosaic X5 maintained enough observability for our flight to proceed, aligning with the earlier outcome where our X5 equipped the vehicle completed the route under jamming, while others didn't. The signal level perspective explains why the navigation solution is stayed and usable despite the degraded CNO. Sufficient satellite remained trackable to sustain a solution until the interference is subsidized. Next slide. On this slide, we're looking at the front end. As a wrap up, I wanted to bring the focus back to what truly enables a safe and reliable swarm flight at scale, resilient and secure GNSS performance. Our IFO platform integrates AIM Plus, a protection framework that provides both anti-spoofing and anti-jamming capabilities. This means our drones aren't just precise and they're protected. Thank you very much.
Hi, Jon, thank you very much for that presentation. Very nice to see that it's not only JammerTest, right, that we have as an event for testing, but many indeed of the customers actually of GNSS, they want to do their own testing in jamming and spoofing, and definitely you're in Korea, so it's great that you managed to have a very good testing there. I know that we noticed also that it was quite some heavy testing, heavy jamming, sorry, in the environment there. So thank you very much for that. And for the experience that you have in these specific light drones, which is definitely a beautiful type of use case around drone applications. And actually, this is the time for our Q&A session with our speakers. So if you have a question, please use the question box in the console. We actually already got several questions, so if we don't select them, please don't worry. We'll make sure that your questions are answered after the webinar. And my assistant also, you will help us also in the chat to type some of the questions. We have a great team also that is answering some other questions as well in the back. Thank you everybody for that. And let's start actually with those questions, but before, let's make sure that we are all visible also in the camera so that we can have a nice discussion around this. There. And let me go to the first question actually that I have here. And the question is, how real is the jamming and spoofing threat today? I think all of you have talked about this in your presentations, but can you really tell us how real, do you see this already in your use cases? Lisa, you are also quite a lot involved with not only the policy people, but also with the end user integrators. What's your view on that?
You know, it is real. It is very real in certain parts of Europe and the Mediterranean states where there are armed conflicts taking place. The part about it that's really difficult to really understand is the predictability, right? That it's popping up in one area and then over here and over here and over here and over here.
Mhm.
It's not a persistent all the way around the globe every single day, every single time. But no matter where you're taking your receiver or device, you need to know that you are resilient to that jamming and spoofing, no matter where it might pop up.
Yeah, indeed. Hayon, I mean, you already, of course, are integrating this technology, which is definitely nice to see the testing you did. But I mean, I have seen also a lot in the news that there are sometimes indeed this type of shows affected by the jamming side. Can you comment on that? What do you get to see from the customer side?
Not only the actual jamming or spoofing, but also the EMI and many radio frequencies that could potentially fall into the category of jamming is also one of the important the matter that we need to protect. So I think in that regard, the Septentrio technology can help us to avoid such erratic technology hiccup in the live event.
Yeah, and you have very small drones there, lots of EMC, I can already imagine there, and lots of drones also talking to each other with a lot of communication. So yes, it's definitely interesting to see that. Samuel, you get a lot of use cases, I guess, from the support team as well. Can you comment on that? How real is, I mean, not only of course in the geopolitical areas, but yeah, what happens in other type of private industries?
Yes, indeed, it's becoming really real. We've seen many of these customer cases where we get these different types of jamming and spoofing that's going on, even outside of combat zones. Like for instance, in the Baltic area, we see some type of Chirp jamming there, and with all of these devices, spoofing devices or jamming devices also being more easily available, it's just much easier for kind of anyone to do this kind of spoofing and jamming. And we really see this, and from all of this data, we keep improving on that. And I think, for instance, JammerTest is really the tip of the iceberg there with all the different scenarios that they keep up to date every year. And that really makes clear how real the threat is, and that we need to stay on top and keep updating against all of these threats.
Actually, that links to the next presentation, actually, Samuel. Sorry, the next question that we have here, which is, what did JammerTest 2025 really change in our understanding, and how can we do better? Is it mimicking really live scenarios in both the conflict environments as well as the commercial applications? I mean, you have presented in the different type of scenarios, but I'm pretty sure that there was even many more scenarios there. Is it really mimicking that?
Yes, absolutely. They keep it up to date every year. They actually do an awesome job of keep innovating a kind of their type of attacks that they use. They go from military types of jamming for which they use special equipment, also to the handheld ones that you can get easily yourself online. And for the spoofing one, they keep it sophisticated. They kind of keep creating these new attacks. And every year we see all of these new things. But all in all, we can say, as we showed in the presentation, that we do quite well. There are areas of improvement every year, of course, but that's the real value of this JammerTest.
These events, indeed. Lisa, you also got several people from the industry that attended the event. What was the feedback there?
Very appreciative. They found that exactly as Samuel said, that it was real world, that they were able to spend the time there, knowing that it impacted the local area, the local residents and workers' lives, that they were able to go in and do exactly what they needed to do to get the kind of feedback and information they needed to continue to innovate every single time. It's been a really great opportunity, and we're seeing more and more industry representatives interested in participating. So that to me is a great sign that it's going well.
Definitely, and I hope there are more events, by the way, also which are more publicly available on that. I'll move to the next question. How should resilience performance actually be measured and compared? I mean, all of you have also shown, of course, different levels of resilience protection side, but how the performance should be actually compared. Hayon, I mean, you did some testing, which is already from the user perspective, very interesting to see. How do you think you can do this type of comparisons better and better, especially when taking a look at the technologies of GNSS?
The testing, jamming, and spoofing is really hard because it is the mostly illegal in I think the most of country. So having this opportunity to prepare this kind of abrupt technology problem is really important. So we are lucky to test with the actual in the actual environment. So I think having this opportunity in a controlled environment would help us to understanding with the other integrated system like drone, not only the signal integrity, but we also saw that the problem happens in real on the drone was really helpful.
Yeah. Thank you for that. What you think, Lisa? I mean, there is a lot of talks on the industry. You mentioned even the definition of resiliency as a first step there. But how can people start to compare these systems and measure them better?
Well, you know, this is actually where I think political will comes in. That is an important component of this. That as Hyan mentioned, these activities are illegal and they are inconsistent with the agreements that governments made and at the ITU, inconsistent with the entire theme behind the International Civil Aviation Organization, which puts a primacy on safety. So I think those safety standards that are in place for particularly public safety applications like aviation, like maritime and others, are essential, important standards that these types of receivers and devices need to be able to withstand, so that it does include, does actually ensure that public safety is okay. And we really need some political will behind that to make sure that interference-free zone continues to be the daily standard.
Alexander, I agree. But indeed, it's very nice to see there is definitely much more awareness. I can definitely see that. So thank you, Samuel. I mean, from the technical side, how can people do this type of measurements, testing side? What would be your take there?
Well, yes, of course, it's kind of difficult to come up with like the one metric to compare all of these things. It will, of course, depend on what the user needs from the receiver. Because otherwise it would have been quite a short presentation, just show this one metric. And as we saw, there were multiple different things that we could show. For instance, position availability or awareness, like for instance, the spoofing flag. For some users, it's just important that the receiver reports when it's, and the position is trustable and things like that. But all in all, it depends on what the user needs, depends on the application. And going from there, you can just look at the data and do all of these comparisons.
Yeah. I think, as you mentioned, indeed, different applications have different requirements in terms of resiliency. Some are maybe less affected, but indeed, if you're in a more critical situation, even as an example in the light drone shows where you have a big record actually of drones flying over the air, definitely you need that safety, right?
Yes,
in sake of time, actually, I will move to the last question actually that I have here, and this is a bit for everybody. Looking ahead, what will define trusted GNSS in the next 5 years? What's your take on that? Let me start with you, Lisa.
You know, I think what would define trusted GNSS in the next 5 years is that we're no longer having to talk about jamming and spoofing as a daily occurrence. That it is something that governments have come together and said, yeah, we need to start enforcing and adhering to the laws and the international standards to which we signed up for, and that we're talking about some of the newer applications that are coming out every single day using GPS, Galileo, and other GNSS, and not talking about these harmful interference events anymore.
Definitely. Samuel, what's your take?
That's not an easy question, Gustavo. I've only been into GNSS for less than 2 years, so how it will look like in the next 5 years. Well, of course, in my short time that I've been in this industry, it's already clear that there have been quite some changes during the technical aspect, like this type of jamming and spoofing that we see, and just the improvements from the receivers that we also see. And then in the next 5 years, of course, it would be the best if all of these threats are not there anymore, like Lisa is saying. But you cannot assume that. So for us, it will be like keeping improving our products and making sure that we can stay on top and improve our resilience together all of the threats likely increasing as well.
Definitely, as you show it, indeed, is the cycle of improvement, definitely learning and improving all the time, and maybe bringing new technologies as well. So definitely interesting. Hayan, what's your take on that?
I think the signal, the satellite's GNSS signal is not what we can see. So I think the trusted GNSS receiver or module should make us to see what's invisible, including the jamming and spoofing. So even though the jamming and spoofing happen, we're there's no way to know in person. So I think the technology should report what's happening and what we should do, and even mitigate those kind of noise to provide accurate position navigation solutions.
Yeah, I totally agree. The system should be as transparent for you in order to just keep trusting the system and continue your operation. So actually, unfortunately, we have to conclude here. We're already a bit over time, but we'll make sure that all the questions that you ask are answered after the webinar. I want to thank all the panelists, our backstage team also, who has done quite a lot of answering of some questions also that pop up. But I also want to thank the audience for joining us today. We hope that you found this webinar informative, and stay tuned because there will be definitely some extra news from Septentrio, definitely this year around resilience and definitely products part. And before we finish, we'll leave you with a short video showcasing highlights from the JammerTest campaign. And as I say goodbye, I encourage you to visit our website for more content and enjoy the closing video. So thanks everybody, thanks to the speakers, and bye-bye.
Together under northern sky, engineers and pilots testing signals side by side, jamming the system, spoofing the time, learning together, no one stands alone. JammerTest, sharing is caring, side by side, cooperation we ride. In the sea, planes lost somewhere, drones don't know their location, ships on the streets,